Factoring algebraic expressions. To factor an algebraic expression is to write an equivalent expression that is a product. An equivalent expression of this type is called a factorization. In other words, you can think about the word factor as the process. It's something that you do. It's the verb, an action. The factorization is the result of the product. It's the result of the process. And so you can think of that as a noun. It's the end result of factoring. The word factorization should sound familiar because you've done this when you've done prime factorizations. So let's look at how to factor monomials. So factoring monomials, to do this you simply list all the possible factorizations of each monomial using only positive integers as both coefficients and exponents. So we'll begin with the monomial 42. And so the different factorizations of 42 could be 1 times 42, 2 times 21, 3 times 14, 6 times 7, or even 2 times 3 times 7. And that's our prime factorization, 2 times 3 times 7. Listing the factorizations of 12x to the third takes a bit more time because we have to include our variables as well. So of course you can think of the different combinations using 1, like 1 times 12x to the third, but you could also say x times 12x squared, or x squared times 12x, or x to the third times 12. Then you could think of our combinations using 2 and 6. 2x times 6x squared. 2x squared times 6x. 2x to the third times 6. You could also say just 2 times 6x to the third. And then you could also list all the prime factorization, all the factorizations of 12x to the third using the coefficients 3 and 4. So 3 times 4x to the third, or 3x times 4x squared. And you could think of some more combinations that you could make as well. For now, we'll go on and look at how to factor other types of polynomials. So if factoring monomials is just simply listing out the different factorizations, factoring polynomials, you have to think about using the GCF of all terms. Remember the word GCF, the letters GCF stand for greatest common factor. And to help you think about this, you can think about factoring as the inverse operation of distribution. So distributing means you take a factor and you multiply it into two different terms, whereas factoring, you think about it as the inverse. You find the common factor in the two terms and you factor it out of them. So let's look at how to do this with the two examples below. Factor each polynomial completely. First, our trinomial, we look for a GCF of 6xy plus 18xz plus 3x. And our greatest common factor would be 3x. You have to include both the coefficients and the variables when looking for a greatest common factor. So if we factor out our GCF of 3x, what would be left with is 2y. You're thinking about dividing out that 3x. Plus 6z plus 1. When you factor 3x out of 3x, you're left with only 1 as your last term. With our second example, our greatest common factor of this binomial would be m to the third and n to the second, because there's no common factor of 5 and 9 besides 1. So when we factor out our m to the third n squared, you're left with 5m squared minus 9n squared. Before going on to the next slide, why don't you pause the video and try to do the next two examples on your own, and once you have your answers, resume the video to make sure that you've got them answered correctly. Okay, now you should have done 3 and 4. Let's look at our answers here. Our GCF of number 3 should be 7y, and that would leave you with, inside your trinomial here, you're left with 2y squared minus 5xy plus 1. And for the last example, our GCF should have been xy. And so that would leave us with x squared y squared plus 4x minus 3y minus 1 at the end. Now let's look at one final example. What if a polynomial cannot be factored? Let's look at the polynomial below. 35x to the third plus 14x squared minus 7x plus 8. You'll notice in all 4 of these terms, there is not a single factor that is common of all 4 of them besides 1. And so if there are no common factors and a polynomial cannot be factored at all, we say that the polynomial is prime. But before we start listing lots of polynomials as prime, we're going to learn multiple techniques to learn how to factor besides just using the GCF. So for right now, every polynomial that you'll see will be factorable, but later in the unit you'll begin to see more and more polynomials that are indeed prime.